So in Vectors 1, we're going to look at scalar quantity, just an introduction to what it is, and then we're going to go on to look at vectors. And this is your first video on your journey of a 2-year applied maths course in which we're going to use Ollie Murphy's book, The Fundamental Principle of Applied Mathematics. So what is scalar quantity? Scalar quantity kind of is what it is. It is what it sounds. It's measured on a scale. So height, length, area and speed are ones that you would have come across at junior cert. And what are vectors? So vectors have both magnitude and direction, and they're represented by letters with an arrow on top. So if we take, say, the velocity of the wind could be going in this direction, northeast, and it could be going at a speed, let's say 20 kilometers per hour in a northeasterly direction. Northeasterly. Acceleration. Well, the most common acceleration that we're going to deal with is gravity. So if we take acceleration towards the ground, an apple falling from the tree is going to be at 9.8 meters ms to the minus 2, or m over s squared. Displacement is a position relative to a given point. So if we take displacement, if we take this is Dublin and this is Cork, Cork might be just approximately let's say about 200 kilometers, and that will be southwest of Dublin. So this is displacement, a position relative to a given point. For force, let's say we have a big block that needs to be moved, and we have a father and son with the same length of rope moving this block, but the father is going to be stronger than the son. So they're going to move this block with different forces, and this is where vectors comes in. So which direction is this block moving in? So if the father is pulling in this direction, now the longer vector represents a bigger force. And to create a vector, what we do, we take our two lines, we call F and S. I draw a dotted line from S, the tip of S, parallel to F, and I take the top of my F and I draw a line parallel to S. And where these two lines meet, this becomes my vector, which we draw in a single line. So this is my vector along here. So this is F, and I should give these an arrow. This is F plus S. This is the force that's going to be impacted on this block. So this is my vector A. The vector minus A is the same length in the opposite direction. Similarly, if I draw A again, this is the vector A. The vector 2A is in the same direction, but just twice the length. So this is 2A. And of course, if that's the case, then the vector 3A, and these are just approximate drawings, you'd be drawing this with a ruler. The vector 3A is 3 times the length. So we can have minus vectors in the opposite direction, and we can have a vector multiplied by a whole number or a fraction, and that will extend the vector or reduce the vector if it's between 0 and 1. So if we have a vector that looks like this, A and B, you're asked to construct a vector 3A minus 2B. So we extend A out 3 times its length, approximately, get to here. And if we go back in the opposite direction to B twice the length, we'll get to about here. So this is minus 2B, and this is my vector 3A. Don't forget your arrows on top. So what I need to do to construct a vector 3A minus 2B, I need to draw a line, a dotted line, from the tip of 3A parallel to 2B. And it doesn't matter if you extend it too far, so you'd be using a ruler. And we need to draw a line from the tip of minus 2B parallel to 3A. That's slightly off. Let me just go a little different direction there, about here. And where these two cross, we draw a line from the point where A and B meet, and this is my vector here, this is my vector 3a minus 2b. So really straightforward. You'll be using a ruler and a straight edge to get these lines exactly. Measure A, measure B, and constructing your vectors. So let's have a look at the questions in Fundamental Applied Maths. They're on page 4 in the book. Exercise 1A. There's 9, 10, 11 questions. We'll do a selection of them because they're all very similar. So part 1, just construct A plus B. So we don't need to do any extensions. From the tip of A, parallel to B. And from the tip of B, parallel to A. Got my point. Construct my vector. Put an arrow on the top of it. This is my vector in here. A plus B. Really straightforward. So again, we're asked to construct A plus B from the tip of A, parallel to B, from the tip of B, parallel to A. Got my point. Where the two lines meet, construct your vector. A plus B. So question 4, a half x minus a half y. Well, a half x will go to, let's say, this point here, minus a half y back in this direction, halfway to this point. Drawing your lines, your dotted lines from your tips. So from the tip of a half x parallel to minus a half y, and from the tip of minus a half y, we got our crossing point. Construct your vector. So this is the vector, a half x minus a half y. So the rest of them are pretty straightforward. I'll do one with 3 vectors, question 5 and 6. So with a vector like this, we construct A plus B first, and then we do A plus B plus C. So A plus B from the tip of A parallel to B. From the parallel of B, from the tip of B parallel to A. We construct this vector. So this is the vector A plus B. Now we're looking at this vector with C. So from the tip of A plus B parallel to C, it's down this way. And from the tip of C parallel to A plus B, that way. And from where these two meet, we construct our vector, and it's not far off the line B. Just rub that out and do it again. So this is my vector A plus B initially, and then we're adding plus C onto that vector. So question 6 as well, very similar. So it's the same vectors that were given, and now we're asked to find A plus B plus C initially. So from the tip of B, going down, from the tip of C, going across. So this is B plus C. B plus C. And A plus this, so we're going from the tip of B plus C, parallel to A. And we're going from the tip of A, parallel to B plus C. And where these two meet, which is this point here, I'm just over exaggerating so you can see it. We are drawing my vector in this direction. So this is a vector A plus initially B plus C. So you should have a good idea now of drawing these vectors. So we'll go on to question 9 now. 9, 10, 11, where there's words involved as well for your final 3 questions in this lesson. Okay, question 9, worded question. U is a vector 3 centimeters long in an easterly direction, and V is a vector 4 centimeters long in a northerly direction. So let's sketch these. U going in this direction, and that's 3, and V in a northerly direction, and that's 4 cm. So U plus V, just change colors here, U plus V is obviously in this direction here. Now, you might identify this triangle as a really common triangle that you've seen at junior cert. You may even recognize the angle. So I'm just going to shade in this triangle and then take it outside the diagram, which in applied maths we're always going to be drawing diagrams as accurately as possible, and then we can separate what we want outside the diagram if we need. So this is my triangle, this is 3, this is 4, so immediately at higher level applied maths you have to see that this is 5. So we have theta. So 5 is my magnitude. And my direction, I can use sine, cos or tan because I have all the sides. If we only had the 2 straight sides, which we probably will use tan a lot in applied maths, the inverse tan of opposite over adjacent, tan minus 1, the inverse tan of 4 over 3 will give me theta. So in this case, theta, if we round it off, is 53 degrees. Now, in what direction is it? It's 53 degrees. So the way we will write this is, we'll write it's going east, 53 degrees north. So if you did the same for cos and sine, you get the same angle. In question 10, similar again. And question 11, similar again. So let's have a look at the two of those. So in question 10, you are asked to use a ruler and a protractor and find the length and direction as accurate as you can. But we're going to do this mathematically rather than just estimating. So x is a vector 5 centimeters long in a direction 30 degrees north of east, and y is a vector 4 centimeters long in a southeast direction. This southeast direction, I'll just do a little sketch up here. Southeast is going in this direction here, and if it's southeast exactly, these are 45, and we're going to see this a lot in applied maths. So we're going to draw an east, west, north, south diagram for these two vectors, and we're going to use the sine rule in this case to find exactly how long they are. So let's have a look at x, 5 centimeters 30 degrees north of east. So let me just do my, what we're going to call IJ axis. So I'm going to sketch an IJ axis, or an XY axis as you would have seen at junior cert. And we'll be developing in vectors too, we'll be looking at the I and J plane. So this is just considered an X and Y axis for now. We're dealing in X and Y here. So X is 30 degrees north of east. So you could sketch this quite accurately. You can see where 45 is just with a diagram like this one up here. So 30 degrees approximately a third of the way up here. So let's call this X, and that's 5 centimeters long. And that's my vector X. Y, 4 centimeters southeast. So southeast is, if I split this halfway, that should be southeast approximately. And if you measure that with a protractor, you can see it's pretty accurate. And this one is 4 centimeters. And that's my Y vector. So now let's sketch my X plus Y vector. So parallel from the tip of Y, parallel to X. I'm going to come a bit too far here. And tip of Y, tip of X parallel to Y. Now, does it look like it's along here? Does it look like it's along this x-axis? Well, let's see now in a minute. So this is my vector. I'm going to do it in blue over the x-axis. It looks like it's along here. Let's see, is it along here? X plus Y. So let's put some angles in here. 45 here. This is 30. If I just do another line on top here, we see we'll be able to add more angles to this diagram just to do it exactly. So you can see alternate angles. This one in here is going to be 30 and this one will be 45. So this one is in fact 75, 180 minus 30 minus 45 would be this one in here, which is 105. And you can see if that one's 105, this one has to be 45. So in fact, these are alternate angles. So the x-axis, in this case, it is along x plus y. And similarly, this would have to be 30 in here. And this one down the bottom would also have to be 105. So I have my x plus y. I'm looking for the length. The direction, it's definitely along this x-axis here. It's going to continue along this way. So that's easterly is my direction. So now let's have a look. I have some measurements on this triangle. So let me just, again, like the last question, I'm going to take the triangle on top here. I'm going to take it outside. And you guys, you may have been introduced to trigonometry in 4th year where we did the sine rule. So I'm just going to call this, well, I'll call it x plus y because that's what it is. But we normally just give one letter to the unknown. This is 5. This is 45. And the sine rule states a over sine a, or sine a over a, is equal to b over sine b. So when we have a side here, let's call that one a, and we have the angle opposite it, which is 45 in this case, I'll be able to work out my unknown. I'm going to leave it at b, let's call it b here, just so we don't have to write x plus y, over the sine of the angle opposite, which you can see from the top is 105. And that should be sine. So 5 times the sine of 105 is equal to b times the sine of 45. As higher level students, you're going to be able to just skip that line and just write 5 sine 105 over sine 45 is equal to b. So if you type this into your calculator, b comes out on my calculator, and it should be on yours too, as 6.83, and that will be in centimeters. So this vector x plus y is equal to 6.83 centimeters in an easterly direction. Now, try question 11, and then you're finished with this lesson. Okay, so question 11 is really straightforward. X, 12 centimeters due east. Here we have x, 12 centimeters. Y, 5 centimeters due south. You may recognize, I'm not drawing this to scale. You may recognize, we want this big diagrams in applied maths so we can see. So it doesn't really matter if the 5 is nearly the same length as the 12. And we want the magnitude, or the length of x plus y. And you may recognize this 5 and 12 from trigonometry. So there's my line, deliberately too long, parallel to y. So here's my x plus y. So here's my vector x plus y in green. So with a 5 and a 12, you can see the answer is 13, but I'm going to take the triangle out from the diagram. Here's my 12 from the top, my 5 from the side, my x plus y. And you can see here that the square root of 5 squared plus 12 squared, so Pythagoras comes into a lot of these questions, is equal to 13. So that's the answer to question 11. So that's lesson 1 on vectors. Go on to look at lesson 2 on vectors. The I and J plane.